Hello there, everyone, and welcome to another GDS WinBidPro webinar. We will be talking about how to set up and use CAN systems, or stacking systems they're also called, and that is what we're kind of looking at here on my screen. So actually, hopefully you can all see this well enough. The version I'm using right now is 15.2.7, and that's going to be released in the next few days here on our website, so don't forget to check our website for the latest version of WinBidPro. And we're using the YKK catalog right now, and there's already, like most of the catalogs in our program, a lot of them already have pre-configured CAN stick systems, so those are going to be visible in the catalog, whether you can type in the filter bar here for CAN stick, or if you just browse through your catalog. So for YKK, they also call them window wall in YKK, but the main thing about these systems, like let's go ahead and just create a new job here. So we're going to call it new job CAN test system. The color doesn't really matter here. So I am going to, again, filter for that. I can see that there's 5 different systems. So I'm going to use a 1-inch glass system just to pick one. And then we're going to start with a fresh elevation here. So let's say there's 6 panels, 225 inches wide, 120 inches tall. So now this system, I can tell just by looking at it, this has interrupted head and sill components. It has a sill receptor, which we can see here in the drawing is 3/8 profile. So the way our software works is what you see is pretty much what you get. So the length of this vertical here, you can see that it's not interrupting the sill component, and it's not interrupting the subsill, and it's also not interrupting the head. So the distance between the inside of the head and the inside of this sill is going to be the cut length of that vertical. Now, of that wall jamb. So if we look at the verticals, however, the verticals interrupt the header, the verticals interrupt the sill, but they do not interrupt the subsill. So the distance, the cut length of this vertical will be the distance between the top of this subsill, which is 3/8 off the ground, and the very top of the opening. So that's what we're showing with the 119 and 5/8. So that's going to be your vertical cut lengths. So let's just confirm that here. We're going to go into the optimizer. We're going to get elevation parts. And so here's 119 and 5/8. I'm going to make this screen a little bigger. So here we see our vertical material and our wall jamb material. So the verticals are 119 and 5/8, and so remember the wall jambs are shorter because they're not interrupting the head and sill. Those are 115 and 5/8. So that's how it's being drawn. It's just warning me that there's no stock lengths because I didn't optimize. So this isn't typically how a CAN system is configured. So most CAN systems are configured a little differently. So now we'll look at the framing system window just for this elevation. And let's see why these wall jambs are not interrupting the head and sill. So we need to check a box that says wall jambs interrupt CAN. Let's see. Wall jambs interrupt head. So if I were to check this box here, wall jambs interrupt head and wall jambs interrupt sill, then as you know, it's telling me I might need to refresh the drawing. So it didn't make that change, so I do need to refresh the drawing. So now I've changed it so that it is interrupting the head and sill just like the verticals. So that's what that checkbox is giving us control over, is how those wall jambs were being cut. So now a typical CAN system, however, has a continuous head CAN and a continuous sill CAN. So we do have a continuous sill can, but usually these systems, or a lot of times these systems can have flush, the can is flush with the, what am I thinking? There's no reveal for the interrupted components. So I'll show you what I mean. So if we zero out the actual head profile, those are the ones that are in between verticals, and we put in the 2-inch for the head can, and we zero out the sill and put a 2-inch for the subsill. Now we've got the receptors, or the cans, are showing the full reveal of the head and sill. So door jambs interrupt subsill. Oh, that's another little feature. We'll mess with that after we. So I'm going to make it so this message doesn't keep showing up because we know we might have to hit redraw. So I hit redraw. So now it's drawn what I set. So my head can is continuous from wall to wall, and my sill can is continuous. There's no reveal for any filler material or glass pockets or anything like that. So what that means is what we see in between these verticals at 116 is the cut length of these verticals and jambs. So let's go ahead and verify that that's right. So I'm going to, and in order to see that, I need to get my elevation parts, because it can't, it's showing us the old cut length, see the 119.5/8 and then the 115 for the verticals and jambs. So that's a typical thing that you should be in the habit of doing, is getting elevation parts anytime you've changed an opening in your job. So, okay, so now we've done that. Where's our vertical material? Here we go. Vertical and wall jambs at 116. I'm pretty sure that's what our dimensions showed, yes. So simply, that's why I like kind of demonstrating with 2-inch systems, because they're easy numbers to work with. Nice whole numbers. So, and we see on the right here, we've got our 2-inch subsill or sill receptor, and obviously our 2-inch head can. So that's why we're getting the 116. So that's working out okay. Now, a lot of times what you'll want to do, okay, so here's the other thing. Obviously, if you've got a head can or a head receptor, sill receptor, your verticals and jambs need to slip up into these receptors. So right now, since the program is cutting the way it shows it, so it's cutting these as butt joints. But these are not butt joints. These are just, what would you call it, seams or something that show where the part ends and is hidden up inside these cans. So in order to accommodate that, we have to use this little feature down here. It's the add or deduct for vertical mullions and jambs. So this is really intended for can systems so that you can get the cut length right on your wall jambs and verticals. So if we've got a 2-inch system, let's say we need 3 inches of extension, let's call it, to the verticals and wall jambs. That gives us a little room to slip up into the head can and drop into the sill receptor. So, and we can even go less than that, but let's just go with 3 inches. If it's 2 3/4, whatever it needs to be, but you'll see what happens. So again, we need to redraw. Sometimes you have to redraw more than once. There we go. So now what it's showing us, and it didn't used to show this in the older versions of WinBidPro, it didn't show us that there was some extension into these parts. So right now it's showing us that it should be like dashed lines here, but that's something we still need to work on. But the reason there's overlap is because these verticals and jambs are extruding or extending into the cans. So it's fully extending into the sill can, and there's an inch left in the head can, basically. So it's showing us that these, now we're still seeing what you see is what you get, because we're getting longer cut lengths on these verticals. So now let's go to the optimizer, get our elevation parts again. And I don't know if you saw that this number just jumped to 119 from 116. So you remember we added 3 inches to the verticals and jambs, and that's what changed our 116 cut length to 119. So that's exactly what we wanted to get our verticals to cut the right length. So now there's one other thing. There's glass sizes. So let's go ahead and put glass in here. So for glass sizes, I'm just going to pick, we got 1-inch glass, and let's just go with tempered. So our glass sizes, let's see, and I don't know if you know about this, but there's a drawing setting where you can show glass sizes. And when I check that box and I hit OK, I should see my glass sizes here. So here they are. So that kind of saves me the trouble of having to go to my final glass report and look at glass sizes or even elevation glass. Okay, so these are my actual glass sizes where it should be showing me the add to daylight. So, and even if I go back to my layout tab here, I should still see my glass sizes. So again, my daylight is 116 here. So it looks like we're getting 116 7/8, which should correlate to a 7/8 add to daylight down here. So in our vertical add to daylight and horizontal add to daylight, we're going 7/8 over the daylight opening. So that's correct in what we're seeing here. So now, and you can see the difference in the width too. We've got a 35 1/8 daylight with a 36-inch piece of glass. So, okay. So now, if we like that, if there's no reveal for our filler material for the glass pockets, then that's good. But if there is some reveal, then we need to change things around a little. So let's go with this scenario. Let's say we've got 1 inch of head reveal, and then it's a 1-inch, we'll just call it a 1-inch can. So 1 inch of sill reveal and a 1-inch subsill. Now we're still going to have a 2-inch overall, but the difference is now we're adding too much to our verticals. So see, this time it redrew it the first time, so I didn't have to hit redraw. But anyway, you can see our verticals are extending over the top. So the reason for that is since we reduced the height of our, we still got the same overall opening size, but our verticals grew because we now have a smaller subsill and, subsill and head can. So the verticals automatically adjusted an inch, so really 2 inches, one for the bottom, one for the top, to fill that void, but we're still adding the 3 inches. So now we have to go in. So really what we only have is an inch subsill and an inch head can. So in order to slip into that, let's just call it a 1-inch add to the verticals. So hopefully this isn't too confusing. So we've got our 1-inch add to the verticals now, and good, it redrew that correctly the first time. So now you can see right here, we've got the difference between the head can and the actual head filler. So I'm still getting the overall profile of 2 inches for this material. The difference is how it looks. So if your system needs to show the pocket filler as a reveal below the head can or above the sill can, then, whoops, let me scroll up a little. Here, I'm just going to hit 100. So that's how you would do it. Now, you'll also notice our glass sizes are the same. The reason the glass sizes are the same is because the DLOs are the same. So I still had my 2-inch profile. Obviously, my jams are the same profile and verticals. So it's just a matter of how you want that elevation to look. And the one thing, though, that it did affect, as you saw, was the cut length of the verticals. And again, so if I take out, and so here's another thing. So if it's only a 1-inch subsill, or head can and subsill, and we want to change our head and sill material, the actual interrupted material, to a 0.5 reveal, then things are going to change. So let's see what happens. Now, the vertical cut lengths are not going to change, but the glass size has changed. So I changed them by ½ inch each, so we have a 1-inch difference in glass sizes. So you'll see here if I zoom in, we've got our 1-inch profile of the head can and our 1/2-inch profile of the filler. And since I changed a 1/2 inch on the top and a 1/2 inch on the bottom, we added an inch to our daylight opening. So that's why our glass sizes went up by an inch. So you can see the relationship here. So the overall profile of your head and your sill is a combination of the head profile here and the head can profile, and then the sill profile here and the subsill. So, you know, if I take out the head can and the subsill, I know exactly what's going to happen here, but let's see what. So what happens is we're adding an inch to our verticals, and now they're sticking up too far. So now we just have a little 1/2-inch filler, you know, in between verticals, and then that is all there is for the daylight to affect, you know, to affect the glass sizes. So now, to get it more looking normal again, we have to get back into the elevation framing system. Zero out. Now we don't need any adds because we don't have any head cans. And, you know, it's cutting our verticals correctly. We've just got these skinny little intermediate pieces in between the verticals. So, and again, once again, our glass size has changed because our overall has changed. So it's a pretty, you know, straightforward relationship here. So we've got, let's go back to what a typical head can or can system would be. So let's say it's that 2-inch, oh, I'm sorry. A lot of times there's no reveal for the fillers. So we've got our 2-inch, not 22, and our 0 and our 2, and then we can go back. So that is changing our daylight opening, and it's also changing the cut lengths of the verticals and jambs. So we put that back to 3, and then we should be able to see it the way it was once before. So that's it. Now we've got our little bit longer cuts for the verticals, so they slip up into the can. We've got our glass sizes are based on the overall profile, which is now just the sill receptor and the head can, and that's what we're looking at. So let's look at another system here to see what YKK's done. Let's do another elevation. So we're going to do a second, and then let's select the frame this time. I guess they're all on top anyway, so inside glazed 1/4-inch glass. Let's do this. Now let's do a 1/4-inch glass system. Shouldn't be much different, but let's see. So now let's go to 4 panels, 200 wide by 120 tall. Okay. So once again, the way they drew it was to have the wall jambs in between the head and sill, basically, so that they're not interrupting, and the verticals are interrupting. So not sure why YKK would call this a can system. This is why it's important to know how to configure it on your own, because sometimes, a lot of times we'll have the manufacturer set up a catalog for us. Sometimes we'll have a customer even help us set up a catalog. Sometimes we'll do it in-house. And one way or the other, there can be a mistake in a system, and it's going to affect the way things are cut. So the fact that there's no actual head receptor is kind of strange for a can system to me, but that's just what I'm thinking. So again, let's go, and remember that I was affecting only the elevations for that job. So let's say I go back to the first elevation, and then I edit this one. Something we added, oh, I just noticed there's a typo on that window wall. So something we added a little while ago, I can't even remember what version now, this add to master button. So since I've made these changes to this system, it's pretty simple changes, but, oh, the other thing, if we added a head can and there wasn't one, we're going to have to know Oh, see, they had a part number for it, so then it is really strange that they never had a profile for it before. So if you do use YKK, this is something you're going to want to fix in your catalog. So back to this tab here, frame profile. We added this add to master button. So this is a way to save this elevation framing system, which right now is only affecting this one elevation in this job. The master is still its own deal and it hasn't been changed. I can actually hit add to master, and let's go back to framing systems, and it shows up as a copy of you know, the frame that we were working on, the YCN 40. So I'm going to actually highlight this and say corrected, something like that. A lot of times customers will, like if you worked on a system, you can put your initials in there, or you can even put a date, or you can do both. So I could say corrected October, you know, 14 or something like that. And that way you know that it's a system that's been looked at and fixed. So you're confident that, you know, it's the way you need it the next time you go in and need one. So that's something new that we did. Okay, so let's go back to, you know, the ability to add a system from an elevation to the master list. Let's go back to this one. Now we're going to have to fix this system too. So let's jump over to the part numbers. So yeah, see, we have the right part number in there. And I can actually look that part number up here. What is it again? E9-1403. Oops, not ED. E9. E9-1403. Yeah, head sill receptor. So it's a combination. Can handle both situations, of course. So that part's still there. So now let's go back to the profile tab. So really what has to happen is this should be a 2 over here. Not sure why they made the, even if that's the case, even if it's a solid head can with no reveal of the filler material, the fact that you have, here's something to know, the fact that you have part numbers in these columns here, sill material, head material, they're still going to be used, optimized, included in pricing and everything, but if you tell it that there's no profile, it's just not going to show them on the drawing. So the fact that there's part numbers here means they're going to be cut and priced, but the fact that they're out of the actual visual profile just means that it's not going to show up on the drawing, it's not going to affect glass sizes, and so forth. So keep that in mind. And then let's continue on here. So again, if I'm doing that, if I'm making it a 2-inch head can instead of a 2-inch head, I need to remember it's going to shorten my verticals, because if I don't add to verticals, I can tell just by the way it's drawn. That's another actual benefit of the changes we made to show it extend up into the head. So now in this case I left the 3/8 subsill and the fillers are still there. Now the weirdness where it doesn't interrupt the sill material at the end, not sure if that's correct or not, but I guess that's the way it was initially set up, so we'll leave that. But actually that's going to affect things a little bit. So here's another trick. So the one way to do to extend your verticals is, back in this screen, is to do the add deduct for vertical mullions. So now that we're looking at a wall jamb that does not interrupt the sill material, the standard sill material, but the vertical does interrupt it. If I say that the overall vertical length, you know, add deduct to verticals and jambs is 1.5. Let's just do this and I'll show you. So if I add the 1.5 inches to the verticals and jambs, see, now I have to hit redraw a couple times. Oh, okay. I was thinking it was going to give us too much on the verticals, but we're good. So as long as this is the actual cut length you want, so as long as it butts up right here, then we're good. If I guess it has to if it's a regular filler material. It's not a pocket anyway, or it's not a receptor. So yeah, so basically you're adding 1.5 inches to the length between the top of this sill component, a combination actually of the top of this sill component and the subsill. So that was, what are those profiles again? I know it was the subsill was 3/8 and the sill material I believe was 2. Yeah, so it's a 2 3/8 overall profile here. So that's getting taken off of this wall jamb, and then originally it was going to cut it another 2 inches off of it. So the daylight was 115 5/8, which is showing right here. But I've extended 1.5 inches, so it's going to be the 115 5/8 plus 1.5 inches for that vertical jamb. Now this, for the jamb. So the vertical material, the mullions, are a little different. So they're extending through the sill material on top of the sill receptor. So that's only taking 3/8 of an inch off the bottom. And then at the top, it would have been taking 2 inches off, but I added the 1.5 inches. So let's do the math on that. Let's go back to our optimizer. We're going to get elevation parts. So now we've got 2 elevations. Let's sort by part type. And we're looking at, let's look at the verticals for elevation 2. So 119 1/8. Let's see here. Where are we? I'm just going to move this out of the way. So 119 1/8 for the cut length of the verticals for elevation 2. So again, we've got overall of 120. We're subtracting the 3/8 from that. So that's 119 5/8. And then we subtract 2 inches off of that. So that's 117 5/8. And then we take 1.5 inches and add it to that. So 117 5/8 plus 1.5 inches is where we're getting the 119 1/8. So hopefully you followed that. But that's what's happening. So that's what the computer is actually figuring. And in this case, it's figuring the opening size is 120. The combination of the subsill and the sill component is 2 3/8. So it's 120 minus 2 3/8. We're taking away another 2 inches for the head receptor, and then we're adding the 1.5 inches. So that's where, when we look at wall jamb, so wall jamb left for the second elevation is right here. It's 117 1/8. So really the only difference is this 2-inch sill component, which is why there's only a 2-inch difference here. So it was 119 1/8 for the vertical, 117 1/8. So that's all the difference is. This wall jamb is not interrupting this sill component, which is a 2-inch profile. So it's, luckily, in this case, it's easy to see where that number is coming from. So a little bit confusing, but it's definitely a straightforward relationship between not only the glass sizes, which is your overall profile of receptor and component, but also the cut length of your verticals. And knowing that, well, here's one last thing before we leave, before we're done. So this little field here, add deduct for vertical mullions and jambs, is a one value treats all kind of field. So if I enter that value there, it's affecting every vertical and in both wall jambs in an elevation. Now the alternative is to go to the stock length tab and use the greater than less than symbol. So if I say I want my vertical material to be a 1/2 inch less, even though I've added 1.5 inches to all the verticals, the wall jambs and the verticals, but I only want my vertical material, even if it's just this one part number. If I had 3 part numbers here and I only wanted one of those parts, let's say it was a glass pocket or something like that. If I wanted just that one part to be shorter, then I would enter that value here. So I've entered that. It's that E9 1401. Really, it's the only part for verticals. So And right now I'm in elevation 2, so I'm only affecting this one elevation. And I'm going to redraw it again just to make sure it picked up that change. I'm going to go to the optimizer and I'm going to get elevation parts. So now the verticals for number 2. So I'm a ½ inch less. So remember, I was 119 1/8 before. So I've basically subtracted a ½ inch, which gives us the 118 5/8, but only for that part. Now that was the only part. So you'll notice my wall jamb, left and right, are still what they were before, 117 1/8. And again, the vertical before I made that ½ inch deduction was 119 1/8. So a little more flexibility and power. You know, you have control over individual parts as well as these components as a whole by entering a value here. And you could actually subtract too. If you put a negative number, let's just see what that looks like. We can do -2 and hit OK. Now I should see, I'm going to redraw. You see how it shows up short? This is another reason why we did the what you see is what you get, because we wanted you to see what's really happening, what those values are doing. So this is obviously either a problem or the way you want it for some reason if you're subtracting from vertical cut lengths. So that's pretty much how the headcan systems work and the way the program deals with those settings. And again, I've been working in the elevation framing system, but if you go up to your master list of frames and pick one and edit it and do it all the same, make all the same changes we did, then you're changing your master, and from then on, when you pick that system, it's going to have those changes. And remember that how we use that copy button, we were able to save, not copy, but save to master. We saved changes from one of the elevation systems to the master list so that we could use it again later. So that's pretty much in a nutshell how all that stuff works. And thank you again for joining us. And if you do have any questions, feel free to type them in.